Now it's time to look into one more Kubernetes object, that is replica set. And this one is pretty easy to understand. A replica set maintains a replica of your pod. What does it mean? Okay, but why do we really need it? Okay, so we have a pod running on a node and users are accessing it. The pod is running, let's say, some web application. And for some reason, the pod goes down. Uh, the users won't be able to access the service. Of course, if the pod goes down, how can the users access the service? It's completely gone, the blackout. And that's it. The end of the story. Someone needs to log in, delete the pod, recreate it, and fix the problem. It's a lot of work. But if the pod is running with a replica set object you mentioned, these are the pods I want to run. So these many replicas I want to run of this pod. So replica set will do that for you. Any pod crashes, it can recreate a new pod for you, and you can mention replicas for scaling. You can add more pods into the replica set. You can remove pods from the replica set, and when I say replica, it doesn't really need to be really replicas. You can just say one also. So replica one, you'll see. If I have to mention one, so why will I use replica set? That's what the question might be from you. So for we use one replica set basically for health checks. If your pod goes down, you don't need to manually recreate it. Replica set will do it for you automatically, and the best part is you're mentioning more. So replica scheduler will distribute your pods across multiple worker nodes. So in an event of entire node crashing, pods running on that node can get recreated on healthy worker nodes. This is the magic. This is the magic I like. So the best part is you are mentioning more replica scheduler. Well, so then so replica scheduler will distribute your pods across multiple worker nodes. So in the event of the entire node crashing, pods running on that node can get recreated on healthy worker nodes. So let's look into that. Replica set, more about replica sets. Replica set's purpose is to maintain a stable set of replica pods running at any given time as such. It's often used to guarantee the availability of a specified number of identical pods. Mark my word, it will guarantee, and it's used to guarantee the availability of a specified number of identical pods. Now, how a replica set works. A replica set is defined with fields including a selector that specifies how to identify pods. It can acquire a number of replicas including how many pods it should be maintaining, and a pod template specifying the data of new pods it should create to meet the number of replicas criteria. A replica set then fulfills its purpose by creating and deleting pods as needed to reach the desired number. When a replica set needs to create new pods, it uses its pods template. A replica set identifies new pods to acquire by using its selector. if there is a pod that has no Warner reference or the Warner reference is not a controller and it matches a replica set selector, it will immediately acquired by said replica set. So now the question comes is when to use a replica set. A replica set ensures that a specified number of pod replicas are running at any given time. However, a deployment is a higher level concept that manages replica sets and provides a declarative updates to pods along with a lot of other useful features. Therefore, we recommend basically our Kubernetes organization recommends us using deployments instead of directly using replica sets unless you require a custom update orchestration or don't require updates at all. So this actually means that you may never need to manipulate a replica set objects. So simply use a deployment instead and define your application in the spec section. However, let's understand the replica set well with an examples. So this is one example. This is the example we are going to do. So consists of API version, kind, and then metadata. In metadata, you have the front end. App name is guestbook, and 3 replicas we have attached. And a specs, we have a container, and the name of the container is PHP Redis, and image is gonna get from some URL. Now saving this manifest into frontend.aml and submitting it to a Kubernetes cluster will create the defined replica set that pods that it manages. Okay, this is what we are going to do now. Let's jump into the action. Where is my, yes, here it is. So if you have pod running on a node without uh, without uh, uh, with if you have a pod running on node without a replica set, just you created a pod and that node goes down and then pod goes down, that's it, the end of the story. But if it is created with a replica set, it will recreate that pod for you. So we have seen enough theory. Now it's time to look into the action and the practical demonstration. So for that, what we are gonna do is cd root defs lscd. It's a, let me create the new directory. It is mk there, and it's a reps defs and cd reps defs ls. Now here I am going to create my replica.aml file. Okay, so, but before that, let me create that file in VS Code. So let me create this new one. I'll say replica.aml. Yes, so the kind, this is a replica set. Yes, we got it, the replication controller, but I'm gonna go with the replica set. That's okay. Yeah, so kind API version is not just v1, we'll do with the old one, that's apps v1. Okay, and the kind is not a replication controller, or else you can go with the latest version of this also, but we'll use a replica set. Okay, so now it's been changed to the replica dot. So metadata, I'm gonna give this name as front end. Then let's get into the labels. Let's add some labels. Labels app. It's a guest book. Then tear. It's a front end. Then spec. Okay, modify replicas according to your case. So how many replicas that you want to have? I'm gonna put 3 replicas here. And selector name we will attach as match labels. So the selector, I'll give match the labels. That's very important. Match labels. How should I match? Using tear. So front end. Then let's go for the template. Okay. So template is of same indentation as a selector and a replicas. So metadata inside the template. So I'll remove this labels. So inside the labels, I'm gonna go with tire front end. So in spite of the label app, my app, we are using tire, and then this is a front end. Yeah. Okay. Match labels is done. Then template metadata labels tire front end is done. Now spec. So spec is container. So name of the container is PHP Redis image. Let's take from GCR. Okay, for that let me get into the documentation of that so that I can get that. So replicas, where it is GCR, Google Cloud, I think Google Container Registry. Let me find out. Yeah, here it is. And app 1.0. That's hello app 1.0. Let me paste it as an image. And that's it. Then rest all is fine. So no port is required in this case. So let's it's part of controller. Ports are not required. Let me remove this. Save this and control all and paste it here. That's it. So let me do ls, and replica.aml file is absolutely ready now. So once the manifest has been saved into frontend.aml definition file, and submitting it to your Kubernetes cluster will create the defined replica set and the pods that it manages. So let's do that. So kubectl apply, and F option we can go with, and then name we have to mention. So either you can use apply or create. I'm gonna do with create now. Create F option, and it's a replica.aml. Let me click enter. Yes, that's it. Replica set.apps, a front end created. Let me copy this and put it in sticky notes so for the later usage. Okay, that's it. So now let's look into that. So how many pods we have? So kubectl get pod There are a lot of pods are there. Let me delete all these pods one by one because anyway these are not required. So now we are going to use a replica set. Okay, it's already been created, 3 front end. That's fine. Anyway, now let me delete all others. Only will keep these replica sets. So kubectl, delete, and pod nginx f, and there are a lot of. Okay, now let's kubectl get pod. Okay, nothing has been deleted because these are also replica sets only. Anyway, but now we will look into this, the front end stack. So clear the screen, and now let's look into the front end stack only. Absolutely. So I'll say this kubectl get rs, that's a replica set. You see that we have two replica sets. One is front end, just 2 minutes ago we have created. Other one is nginx tip, nginx deployment a replica set. This is using deployment. This we have done it using deployment object. Okay. Anyway, that's fine. Our focus will be on front end only at this moment. Now let's do kubectl get pod, and all three are up and running. Now I'm gonna delete 2 pods out of it. So kubectl delete pod. I'll take front end bg pjt, and front end gd nsb space, and enter. So these 2 pods has been deleted. Now let's do kubectl get pod and see what's gonna happen. And here it is. These 2 pods bg pjt gd nsb, these 2 pods has been deleted, but the new 2 pods has been arrived. That's a bk b2t ljjgp. So these are the new pods. As soon as the pod gets demolished or destroyed, a new pod will be created. That's the power of a replica set. So now let's do a configuration, to little more configuration to this vim, and then it's where is that file? ls, yeah, vim replica.ml. So I will change the replica size. I'll put it as 5 or 6. I'll put it as 6. That would be better. Yeah, let me save it and quit it. Now let's execute that again and see. So kubectl apply this time. Last time we have used create. Now I'll use apply, and the file name is replica.ml, and you see that warning. See the warning. Resource replica sets front end is missing the kubectl.kubernetes.io. Last applied configuration annotation which is required by kubectl apply. So kubectl apply should only be used on resources created declarative by either kubectl create save config or this, whatever it may be, or replica set dot front end has been configured, whatever it may be the message, the warning, but it's been configured. Let's do get pods. You should say that 5 front ends now. 5. You see, all 5. So this is a declarative way of scaling up. We can do the scale up, scale down. Now we'll do the scale down now. So vim, and this time I'm gonna say just 2. Let's see what's gonna happen. Scale down. Yes, replica set dot apps front end configured. Now let's get the pods. You see that only 2. Front end BKB2T, front end LJJGP. Only 2 are left. So that's how we scale up and scale down declaratively. So now we also do the imperative using commands. Imperative scale up and scale down. So for that we have to give a command. So kubectl scale, and option is replicas equal to 1, and rs it's a front end. That's the name. Let me say 1. So it's been scaled. You see that replica set dot apps front end has been scaled. Now let me do kubectl get pod, and it's just 1 front end ljggp. Now this time I'm going to scale up imperatively. The last time we have scaled down. Now let me do the scale up. Let me make it 7. So the replica set dot apps front end scaled. Now let me see kubectl get pod, and you see that almost 7. It's close. It's 7. Okay. Now let's do the scale down to 1. Just 1. And kubectl get pod. You see that you have only 1 ljjgp. So that's how you scale up and scale down. Now let's edit the replica set front end def file. For that I'll say kubectl edit rs front end. Yeah, here is that file, API version apps /v1, and kind is a replica set. Here you will find the metadata completely. Then here labels, 2 labels, tire front end and app guestbook. Name is this, and namespace, a resolution version, and UID. And this is the YAML file, the complete information of that front end replica set definition file. Let's do WQ. So it's all done. Now it's time to delete kubectl get all, kubectl get pod. Now let's remove the replica sets. Just say delete rs front end, or else you can say rs / front end without space, whichever is fine. Did you mean delete? Okay, that's my mistake. Let me remove that. Yes, I meant delete. So replica set dot apps front end has been deleted. Now let us check kubectl get pod. That's it. It's gone. You see that? No front end LLGP or anything. No front end LLGP. This is how we handle the replica set, and always it's better to have a replica set. However, you need to you can use the better option, that is a deployment.